It is an example of strawberry jam creation algorithm. You can see all these steps and the pictures that explain how can we work with strawberries. Um, the very similar process is to handling with spatial data. We have raw data, then we purify this data, homogenize this data, and then manipulate this data, and at the end we can spatial data store where we can get this data, useful data from the store and use it for our purposes. Uh, well, three observations should be made about this definition. GIS are related to other database applications, but with an important difference. All information in a GIS is linked to a spatial reference. Uh, so the main idea of GIS is to put information on a map. One of the famous GIS software is uh, Map Info. So it can be understood as information on a map. The second one, GIS integrates technology. Various other technologies might be used only to analyze aerial photographs and satellite images to create statistical models or draft maps. These capabilities are all offered together within a comprehensive GIS. So GIS creates a digital environment to connect data of different origins, of different formats in one environment, in one coordinate system. This helps us to analyze all this data together. And the third one, GIS with its array of functions should be viewed as a process rather than a merely software or hardware. GIS are for making decisions. The way in which data is
Sorry,
entered,
but
stored.
we can see your screen.
Sorry. Here we are. Huh?
Yeah.
Yep.
So, do you like this algorithm of strawberry jam creation?
Yeah.
So, and the third observation is that GIS with its array of functions should be viewed as a process. It helps us to make decisions. The way in which data is entered, stored, and analyzed within a GIS must mirror the way information will be used for a specific research or decision-making task. So we should speak about data domain. Uh, uh, well, who can explain what does it mean data domain? Uh, Shortly speaking, data domain is kind of field in which This data, we should use this data. Here we see an examples of GIS application areas, geology, agriculture, and so on. The earliest existing maps were made by Babylonians about 3000 and 2300 uh, before Christmas, BC. Uh, cut on clay tiles, they consisted largely of land surveys made for the purposes of taxation. The earliest known maps are drawn on the parchment to show the gold mines at Copts during Ramses II in ancient Egypt. During the 20th century, mapmaking underwent a series of a major technical innovation. Aerial photography accelerated the progress of mapmaking. The first aerial photo was used for mapmaking is mm, they said that in 1809. So sorry, 1909. Photogrammetry, the technique of making measurements from photographs, was developed rapidly during World War I and used extensively during World War II. After the World War II, photogrammetry became widely used in map making, mostly for maps of uh, bigger scales. The basic concept of a GIS: the surface, subsurface, and atmosphere of the Earth. These levels or uh, different themes of the landscape. Interpretation and explanation apply to those data and organization framework for understanding the information. We can get useful information directly by measurement. For example, make a ruler on a screen to measure the distance between 2 points. Another way is remove sensors, temperature, humidity, etc. In situ observations, you know, as ecologists, how to get in situ observations in the field, in the forest, on a seashore, and so on. Then defined through survey or legal description. Survey is a process of gathering of different spatial data capture. Not only spatial, uh, probably demographic data or election data on election. Um, and the fifth, interpreted from data analysis or simulation. Uh, so we get new data from input data sets. Geographic information obtains meaning from both spatial and non-spatial aspects, uh, where and what. So we use all these models to modeling our world. The GIS being computer-based need to have all of information in the digital form. It is thus necessary to consider how each real-world feature can best be modeled within the computer system. By use of geographic information, a simplified world can be brought into the computer. Uh, well, all the GIS or spatial data have two parts. First of all, position, and the second one, attribute. Uh, well, another third part, necessary and very important part of the every information is metadata. Uh, Metadata means data about data. Uh, what I mean? I mean that, for example, we have a paper map, and we can find that this map was published on 1990. Um, so uh, then we can find who makes this map. Then we can find on the side of the map what technique was used. So this metadata explain what this data about and help us to evaluate this data and nowadays World Wide Web environment is much easier to find necessary data. So all real-world entities must be represented by discrete objects with associated attributes and geographical data must give information about. So spatial data it means coordinates, shape and location of places. Attribute data describes those places, the people, the animals who inhabit them, and the things that happen there. Spatial data enables you to draw a map. Attribute data makes these maps meaningful. So you can see not only the parcels, but uh, mm, information about soil type, building owner, mm, well type, uh, water quality. All these attributes explain the spatial features. All the information in GIS should be geographically referenced. Um, all the data should be stored in mathematically defined coordinate systems which can be reproduced and projected into another systems. Uh, Next week, we should speak about coordinate systems. You probably know Cartesian coordinate systems, and I will share with you some uh, useful information about Earth systems, coordinate systems. Each of these separate thematic maps is referred to as a layer coverage or level. GIS allows us to arrange information about a given area as a set of maps, with each map displaying information about one characteristic of the area. So the main objectives of GIS are to provide a systematic structure of managing complex, diverse collections of geographic information, provide the tools and functions for display, query, map algebra, simulation, and so forth. GIS is a typical data integrator. The primary value of computerized geographic information is integration of different data types and sources in one environment. Uh, well, Nowadays we are speaking about spatial data infrastructure. Every country should uh, make efforts for this spatial data infrastructure creation. This spatial data infrastructure consists of uh, mm, different parts. First of all, people who have enough computer skills, different GIS experts, uh, applications developers, etc. The very important part of this infrastructure is data, which may be of type spatial, temporal, or attribute. Then software that performs various data storage, retrieval, analysis, reporting, and communication functions, and hardware. Uh, so also we can add to this list uh, legislation legislation acts for different countries and international legislation. Uh, how can we use, share, or just capture this data, share this data, and use this data? Who are responsible for data quality, and so on? Well qualified people are trained. Uh, they can have skills for data capture and manipulation. Possibly the most important component of GIS is spatial data. These spatial data are related tabular data and can be collected in-house or purchased from a commercial data provider. Software. Uh, Software provides the functions and tools needed to store, analyze, and display geographic information. Key components of software are tools for the data input, um, data management, data query analysis and visualization, and special GUI for easy access for software functions of software tools. So GIS software provides functions to input and manipulate of geographic information, database management system, geographic queries analysis, and graphic user interface. Hardware. Hardware are different computers, laptops, smartphones, and many modern devices that can gather or capture the data. I will explain all the kind of these devices soon. Methods. A successful GIS operates according to a well-designed plan and business rules, which are the models and operating practices unique to each organization. Here you can see examples of hardware and software. The first step is data input. Before we can use our spatial data in GIS, we should uh, put all the data inside computer. The process of converting data from paper maps into computer files is called digitizing. Modern GIS technology can automate this process fully for large projects using scanning technology. Smaller jobs may require some manual digitizing. Digitizing is uh, making different points, lines, and polygons uh, on a map manually. Before information can be integrated, it must be transformed in the same scale. The scale means degree of accuracy. This could be a temporary transformation for display purposes or a permanent one required for analysis. GIS technology offers many tools for manipulating spatial data and for weeding out unnecessary data. For small GIS projects, it may be sufficient to store geographic information as simple files. When data volumes become large and the number of data users becomes more than a few, it is often best to use a database management system to help store, organize, and manage data. Here you can see examples of data queries. Who owns the land parcel on the corner? How far is it from two market centers? Where is land zoned for industrial use? And much more complicated analytical questions. Where are all the sites suitable for tilapia production? What is the dominant soil type for a manga plantation? If I build a new highway here, how will traffic be affected? With all these maps, uh, data has context and meaning and can be managed and queried far more easily than if the data was presented in tabular format. Another important task is identifying features, locating by specifying conditions where are the object's features which satisfy a particular set of conditions. For example, in military applications, artificial intelligence helps users to find aircrafts, uh, tanks, and other weapons on the battlefield. Proximity analysis. Uh, Proximity means uh, objects situated one from another. Here you can see examples of proximity analysis. Which parcels are within 60 meters of the road? How many houses lie within 100 meters of these main water sources? What is the total number of customers within 10 kilometers of the store? And so on. Overlay analysis. The integration of different data layers involves a process called overlay. It means that one layer uh, lays over another. At the simplest Its simplest, this could be a visual operation, but analytical operations require one or more data layers to be joined physically. For example, you can see, you probably know satellite data about vegetation, so-called NDVI index. So we use different rand near infrared channels or bands to calculate the index that explain how much vegetation or how much chlorophyll is at the area. Well, mm, GIS mainly works with different themes. The ability to separate information in layers and then combine it with other layers mm, is the reason why GIS holds such great potential as decision-making tool in local governments. Another task is visualization. For many types of geographic operation, the end result is best visualized as a map or graph. Maps are very efficient at storing and communicating geographic information. Just GIS provides new and exciting tools to extend the art and science of cartography. Map displays can be integrated with reports, three-dimensional views, photographic images, and other outputs such as multimedia. Well, as it will it was mentioned above, uh, we use position and attributes, spatial and attribute data. Spatial data defines the shape and location of a place and attribute all the necessary information about this place. The main features or spatial elements in GIS is point, line, area, and surface. Nowadays, new spatial elements use, for example, point cloud and maybe some kind of 3D representation, uh, kind of multi-area or multi-surface. The shape used to represent a particular feature may depend on the scale of the map. Um, Here you can see the easiest explanation of points, lines, and areas on a plane. We have uh, two coordinates, x and y, to make uh, this spatial feature as a part of GIS. Well, we also have two approaches to modeling, vector model and raster model. While vector model is a combination of points, lines, and areas, raster model is a graphic data that represent a map by dividing geographic space into a matrix of identically sized cells. Uh, while you are use your photo image from your smartphone. It's also is a raster model. Raster model has evolved to model such continuous features. A raster image comprises a collection of grid cells rather like a scanned map or picture. On the other hand, the vector model is extremely useful for describing discrete features, but less useful for describing continuously varying features such as soil type or accessibility costs for markets. Well, we should uh, distinguish entities and attributes of these entities. In raster model, we have a point of origin, and every entity is a cell, and these cells are situated in the columns and in the rows. The structure illustrates points, lines, and areas as quantized units of geographical area. Grid structure do not allow precise locational information. On the other hand, vector data model uh, divide space into regions by using lines with coordinates. Vector data structure allows to use point with xy coordinates, lines or arcs. Arcs typically have a listing of start points, end points, and intervene, intervening points, and areas, a continuous surface of points with a defined boundary. Well, and mm, using GIS, we should understand all these terms. What does it mean? Aerial photography, geodetic control, satellite imagery, GPS, survey and plot data, uh, thematic base maps, etc. And here, all this um terminology we should understand next week. And thank you for your